Hi, my name is Mitch Dsouza from Oracle, and I'm here to discuss and hopefully do a short demo of using the deploycluster CLI tool for creating Oracle databases on KVM with Oracle/OLVM. So let me start first with a short explanation of deploycluster for those of you who are not familiar with the tool. In a nutshell, it's a tool to create Oracle databases from a VM template. Now, Oracle provides these database templates, so this makes it very easy to rapidly create end-node racks, or real application clusters, or single instance VMs that are fully certified to work on a customer on-prem environment. The tool gives you a well-defined methodology for creating supported database infrastructure that is patched and packaged with the certified OS, which is Oracle Linux. So prior to Oracle embracing the KVM hypervisor, we had OVM. Now OVM is based on Xen, and the previous tool, which is also known as deploycluster 3, was written in Python. And that has been used for customers for over 10 years now. It has had continuous customer feedback driving incremental improvements throughout its lifespan. Version 3, however, is the terminal release for the OVM deploycluster tool. So now let's talk about deploycluster 4. So since moving to KVM, and hopefully you should have heard the presentation from our product manager, John Priest, on Oracle's strategy to KVM, which is earlier in the day, the API that the previous tool used changed considerably. And while a transition layer was bandied about internally, it was not trivial and would actually elicit the same amount of effort, if not more, to do a complete rewrite. The oVirt API set is much richer, and parallelization of tasks led us to instead diverge from Python and rewrite it in Google's Go language, which is, as you well know, probably what Kubernetes is written in. And we used it for its concurrency, threading, type checking, etc. And the fact that we could also output a single binary with no dependencies. Previously, with an interpreted language like Python, you also had to have the Python package installed and all the additional modules as well. So here we can create a single binary, and in the future, we could also create a Mac binary or a Windows binary, meaning that an operator can execute the tool on an OS of their choice, like a laptop or whatever. So just to expand, the new tool leverages Cloud Init for provisioning the SSH keys, the database configuration files, and the YAML scripts that you use to execute the template cluster builds. We can also now provide fire and forget asynchronous operations, or if you like, synchronous operations for use in modern infrastructure as code deployment pipelines. So finally, the tool, while called deploycluster, is not specific to Oracle databases or cluster or Oracle templates. It can be used to do a multitude of other tasks, which will be discussed later on. But the focus here for this presentation is for database deployment usage, and I'm going to show you how we do that. So let's take a look at a typical deployment, and what you would need to do is the following. First, in a deployment with deploycluster, you would have to upload the template via the oVirt GUI to your data center and cluster. And secondly, you would use deploycluster as a one-off single shot via the CLI to deploy your single instance or rack. So just know, step one is a one-off pre-deploy cluster action. Once you upload the template, it's there and can be used for all other subsequent deployments. So this is a one-shot deployment. I call it one-shot because effectively you just run deploy cluster once and it does everything for you. Okay. And the next variation is for use in modern pipelines, for Jenkins perhaps. Here, step one is the same as I mentioned, that you would have to have the template already installed in your environment. But let's say in this instance, you're creating a 2-node cluster and you need 5 ASM disks. In this case, we can split the command in these separate blocks, which is additional 4 steps to not only create the disk, but to attach the disk to the clone VMs, provision the VMs, run the YAML scripts, and wait for a state change, maybe to get an IP address perhaps, or just wait for the VMs to come up. So that's really what deploy cluster does in a nutshell. And it does all the tedious and repetitive tasks for you. While with the performance difference between disk images and direct attached LUNs being between 1 to 2% range, we can just ask deploy cluster to even create the disks for us. So effectively, this tool does it's a Swiss Army, and it can do everything in a single go. All right. So a quick note about the first step. So by now, I'm sure a few of you are asking why the GUI is still required for template upload. Well, currently, oVirt doesn't provide a direct OVA upload feature, as most of you know. You need to push the image up. So you can do it from the GUI, or alternatively via API. You have to push the image up to one of the KVM nodes, and then you need to use the import API to import from a specific directory. Or you need the other option is to decompose the OVA tar file, parse the XML file, and upload the disks via the API, and then recompose everything from a template into a new template. Okay, so that the latter option is actually quite clunky, but it is possible, and we have existing code already to do this. And we're just testing it internally and waiting for the verification process to happen. So we also find a small minor timestamp bug in the API that needs to be fixed, but it's very small. But I need to get that pushed out and logged to take it to the next step. So just to be fair, the tool really exercises the API heavily. Quite a few calls are executed in the beginning to gather all the information up, and then client side we parse all this and we sort it and display it as required. So the type of API calls I use is listing of domains, clusters, disks, and networks, and then creation of disks, creation of floating disks into different storage domains, cloning of the VMs, adjusting the network CPU memory and disk attachments on the clones from the template, starting up VMs and removing VMs and disk attachments, and provisioning the YAML for cloud init. So all these things we do and pass it to the VM before we start them up individually, and then run the deploy cluster script. So let's have a look at the API bugs. I mean, earlier I did mention the timestamp bug in the previous slide, but in extensive testing, we've actually found very few bugs, and we're very, very pleased with the stability of the oVirt API. And one of the infuriating bugs was actually fixed while I was on holiday earlier this month. So I left this sentence in, or this paragraph in, just to show that the API is still in active maintenance mode, and which is very comforting to us in Oracle, the fact that we see work still being done on it, and we're happy with the API that's provided to us for us to use with deploy cluster. So some of the other things that we noted about the API code is it's not always filling in structures that we needed to use, but using the follow API to get the information we needed. But I guess this is part of the design, and not part of the design not to hammer the Wildfly server itself. So I think that's just our learning steps basically into the API, which was different from OVM. So now, let's look at some real life examples. And here is a sample one-shot 2-node rack. Okay, so this command looks quite long. Deploy cluster -c olvm star everything. All that the top line basically. But essentially, it explains what we do. All right. So one thing you'll notice, we use the wildcard in the -c is the create from a template. The olvm is the wildcard name of the template, but you can use a UUID if required, just to uniquely identify it. All right. So here we create three disks for our ASM disk group, ASM 0, 1, 2. And by default, they're 5 gigs each. You can specify the size and the storage domain. Obviously, the storage domain doesn't need to be in the same storage domain as the template or the target VMs that get created. So we can change all that on the command line as well. It's not shown here, but it's in the manual page. And we change the memory here of the template. Say the template was created, with 8 gig here, we can change it to 4 gigs. and we can change the NICs, and we can change, and then we attach the disks to the 3 created disks, which are created shared to the 3 VMs, or rather to the 2 VMs. And then we generate the cloud init YAML file, and we provision keys. We pass the netconfig file and the parameters for the database. And all in all, we tell it to deploy those 2 VMs that we've created. In theory, if we didn't run the clone deploy, the VMs would just stay in the shutdown state, which is useful if you want to spin them up at a later stage and just have them sitting there ready to be spun up. So note that this execution is asynchronous, so it's effectively a fire and forget. And this command typically exists within 10 to 20 seconds, depending obviously on how many disks you're creating and how big the netconfig and params files you're passing, and obviously the slowness of your disks and all that kind of stuff. So typically having fired up this command, after 20 seconds, you'll get your command prompt back, and it will start building the cluster in the background for you without any other further interaction. And you just have to wait for that. So you might have tools to wait for that. You might be happy to just go get a cup of tea and come back to it when it's all finished. Okay, so let's look at the same deployment. And now this is the pipeline. This is using it in a pipeline. So for example, you might have a Jenkins pipeline, and you want to switch that command basically, or split that command into multiple steps. So effectively, you can see if the command fails at any stage, not to wait for the whole thing to run and then fail at the last stage. Maybe there's a error in your netconfig or your params.ini file. So here we create the disk. So you might get an error here. Maybe you have not got enough storage. Maybe your disk names are not unique. Maybe your storage domain is full. So one of those errors you might be able to trap at this stage when you're creating the disks. So the first step is you create the disks. Then you create the 2 clones. And again, this step might error out because you have not enough memory. Your VM names might be wrong. Your NIC names and your NIC profiles might be incorrect. So you might trap an error at this stage and then break out of your pipeline and take appropriate action. So this is the second step. And the third step is actually spinning up the VM. So the deployment, so running the deployment, the second step is just creating the VMs or cloning the VMs from the template. The third step is actually spinning up these VMs, passing the database parameters and the network parameters, and then waiting for the VMs to come up. So here we say wait for 10 minutes. And by specifying the wait command, we turn the command into a synchronous operation. That means the command won't exit until either the 10 minutes has expired, in which case you will get a error code, and the error code can be trapped by a pipeline, or alternatively, if both the VMs come up successfully, it will error out, or it will not error out. It will give you a successful completion. Okay, so this is the way you can split up your command in a pipeline like Jenkins. So since most of the heavy work is done by the template itself with the cluster scripts, all the real work is done once the VMs are created, named, and are up on a cooperating network. However, we do some client-side checks before we get to that stage, not to waste time in the deployment of the VMs. So, some of the checks we do, checks in the net config, effectively bad IPs that you provided, duplicates, net masks are in correct format, the node names are not clashing, your DNS is up, all that kind of stuff that you would expect. And in the params.ini, which is effectively the basic checks for the database itself. So we also check that if you're creating a rack and not on a single instance or a single instance high availability, we ensure that your disks that you're attaching to these VMs are shared. And then we also check that the interfaces are not on the same network. It will pass the check, but it will give you a warning. And I'll show you this as I run the command in a short demo. So we check, that if you have 2 interfaces, they're both not on the same network. One should really be a private network and one may be a public network. And we also check that the SSH keys have been provided. Otherwise, we won't, because the VMs are now using cloud init, we have to have an SSH key. Otherwise, there's no way to log into the VM itself. So there's no username or password provisioned on the templates themselves or on the cloned VMs from the template. So a couple of things to notice: that all basic connection information, and as you've noticed in the previous commands, I don't specify the host name of the oVirt or the OLVM manager. I don't provide the username, the password, the host name. All those kind of things are kept in a deploycluster.ini file, and obviously take the appropriate steps to ensure that the right permissions are on that file, so it's not exposed to anyone else who's on the same machine. So obviously, one crucial thing to note is that with great power comes great responsibility, and you should never use the admin at internal account for deploy cluster, because obviously you can remove, you can obviously denial of service. You can just go around creating loads of disks and loads of VMs, stopping VMs, shutting down, removing VMs, creating different interfaces. So really, you should use with oVirt you have the RBAC facility. Ensure that a suitable RBAC user is used for the deploy cluster itself. Okay, so I didn't mention other use cases are possible. So these are some of the use cases. They've got no affiliation with the Oracle in terms of they're not related to databases, and they're not related to templates. So here's one. You can use JSON to dump and parse your machines or your existing VMs, disks, storage, domains, clusters. What would be a good use case? I mean, so say for example, you wanted to have a look if a machine is up, or what storage is available, or tot up all the storage disk usage for certain users. You can basically list and use the -- JSON, and it would print out everything in machine parsable format. So the second one is maybe you want to create multiple disk images and you want to use it for different use cases. Maybe it's for swap or for whatever. You can create disks and attach them to your VMs. So this is the second example. Is here you create a disk and you're using the name format, which basically the %d is the standard Unix, or rather C printf format. So the %d basically is a counter that goes from 0 upwards, and here basically it'll say we'll create disks -0, disk -1, disk -2 until 4, which is basically count of 5 and sized 10 gigs, and create on the storage domain called NFS. All right. So this will create 5 disks for you in one single command. Right. It doesn't attach it to anything, but you can attach it in another command. So another one is start an existing VM. So say you had a VM already created. As I mentioned earlier, you can split these steps up. You can just say deploy cluster -m and the VM name, which spins up the VM. The no exec is basically states that do not run any cluster commands on that VM. So it won't create a YAML file and provision the YAML file to the machine. So effectively, this is useful for creating, for example, a single instance database if you want, or if you have a non-database machine. So for example, Oracle Linux template, which Oracle also provides on yum.oracle.com. You can just take a template and just spin this up, and it will get a DHCP address and be sitting up in the upstate waiting for you to log into it or whatever you need to do. So the next couple of examples, create multiple VMs from a template. Again, I'm using the name format here. We'll create 5 VMs of 4 gigabytes from a template called template name, and it will change the CPUs to 8 CPUs, 4 times 2 times 1, 8 CPUs basically, and vCPUs I should say, and 2 networks basically. So here's creating, again, if you wanted to create a Oracle Linux template or any other template that you might create, like a golden image, you can spin these up automatically and very simply using the deploy cluster tool. And finally, a quick example of removing templates or removing VMs, shall I say. Deploy cluster -m VM1 and VM2 will remove 2 VMs from your environment, right? So if you look at it, I mean, maybe the tool should have been called template tool, but I digress. I mean, that's for another call. So hopefully, let's quickly now switch to a demo, and let's see if I can show you just a look and feel rather than actually spinning up a whole database, because I didn't do this live. It's not going to be live, so it would take a much more considerable time that's available than this presentation. So it's just a quick look and feel of the tool itself, really. Okay, so here we are on a command line. I'm in my own directory, a demo directory. And as you can see, I've got a single binary called deploy cluster. I've got the initialization file, which has got my username, password, the host name to connect to the certificate authority, and the secure/insecure flag if you're using a self-signed certificate. So I've got all that configuration set up. I'm not going to open that file because it's got my password in it. But let's have a quick look at the netconfig.rack file, which is typically the network configuration. So up to here, typically is the netconfig file, which is a network configuration. Here you can see it's a two-node. It would be a two-node rack that would be creating. This is private IP addresses, so I don't mind sharing these. And these are the names of the virtual IPs and the private addresses and all that kind of stuff. Okay, so just for sake of simplicity, I've added the params.ini file as well to this. You can provision just a single file with everything. So this params.ini is the parameters for the database itself. So this is saying the SID name, the character set, and here are the ASM disks. So I'm going to be using 2 ASM disks. I know this is not right, but this is just for demo purposes. 2 ASM disks for this node, for this rack cluster, effectively. All right. So let's go through, I'll just take this highlighting off. Let's go through a couple of, show you how the command line works. So -L, as I've mentioned before, will list any VMs that are currently up, down, basically running on your cluster. So you can see a couple of things. It's saying, I'm using the default data center and the default cluster, and nothing is reported here. So you can see it's basically empty. I've got no VMs running. But if I use -LT to show you the templates, this prints out all the template, including the blank template. I've got a blank template, Oracle Linux 7, Oracle Linux 8, and the database template here. Okay, the DB rack template here. So you can see the DB rack template has got 2 disks and 2 NICs by default provision, and 2 vCPUs. All right. So I also mentioned in the slides you can use JSON to print it out in JSON, and use the JSON what's the command? JSON reformat to reformat this in pretty format if you want to. But that so that's machine parsable. You can use it with another tool if you want. So another thing we can do is interesting. -LD is list the disk. So you can see I've got 2 storage domains, NFS, iSCSI, and some direct LUNs as well. So this shows you all the disks and the disk images currently on your environment. So we can start by doing deploy cluster minus. I'll just show you create disk, disk 1, disk 2, and size equals 10, but say 2 gigs. I'm not going to use it. I'm going to use the direct. Actually, let's do 5 gigs. 5 gigs and storage domain. So here you can't guess the storage domain you want to create your disks on, so you have to specify the storage domain. Storage domain equals, and I'm going to create it on iSCSI. Quicker for this. So there you go. It's creating the 2 disks, and if I run the -LD command, you will see it created. This takes a couple of seconds usually, assuming my disks are up. So let's wait for it. Waiting 20 seconds, settle. Okay, there you go. So if I do -LD again, you can see those 2 disks appeared here, and by default they're shareable. I could say shareable no, but by default they're shareable. Okay, so let's now create. I'm just going to quickly create. I'm going to use the all-in-one command, which is much easier. Otherwise, it's going to take a long time to do this demo. OLVM. So I'm going to use -OLVM. I'm going to use the wildcard. If you notice, I'll just scroll up here. Hopefully it's still in my, yeah. So this is the name of the template. So I'm just using OLVM, or I could use the full name if I wanted to. Let's use the full name, but I could use that. So create from this template, I want to create, actually, so if you don't provide machine names, I could create machine name VM1, VM2, all right? And I could say minus clone create disk, create disk, disk 4, disk 5, disk 5. So basically I'm saying create 2 new disks, disk 4 and disk 5, and basically attach these automatically to the 2 VMs and spin up the VMs. So I'm going to say -n is the net config that I'm going to provision to it. And I'm going to say -clone deploy. So that's essentially, you can see what it's doing is, again, creating 2 disks, 4 and 5, and it will join these disks. So you don't have to tell it you need to join those disks to the VMs. It'll create, after that, it will create 2 new VMs, join the disk to the VMs, and provision the net config file, add my SSH key, and spin it all up and deploy it into the VM. So you can see it's now taken those 2, it's found these 2 disk attachments, which is just created. So those are the 2 disks it's created. It's attached them to the template. It's attaching these disks to the template, disk 4 and disk 5, to the cloned VMs. And here you go. So within 40 seconds, essentially, it's kicked off the cluster build, and your 2 nodes will be starting to be built on your cluster. So it's also added my SSH public key for the cloud user. I can SSH to the cloud user and now start tailing the log. So essentially, with one command, within 40 odd seconds, you can spin these up. I mentioned here, typically in a rack configuration, you should have one private interface and one public interface, or one on your LAN and one just for interconnect communication. So here it's just telling you, warning, both of them are on the same. You could, with the command line, you can change this as well. You don't need to go in and manipulate it from the GUI. We can change this all on the command line as well. So, and finally, it tells you, the command you would need to use to SSH and see what's going on. So if I just run that command, actually I've got a previous key, so SSH key gen -r10.171, remove the previous key, and if I SSH to it, it should, there I am, I'm back on my rack. And essentially you can see it's running the rack OVM scripts to start up the database cluster under U01. Rack OVM and build cluster. You can see everything is running. So that's about it. I don't want to go further into it. As said, there's multiple options you can use, but this is a quick demo on how you would use it. Okay, so here we are back again. So thank you for listening, and hope you found this useful, and I'm ready for questions at any time. Thank you.